today we're going to be talking about stoichiometry, and specifically limiting reactants.
We're going to be giving you definitions, examples, equations, and lots of fun.
And Krabby Patties.
Stoichiometry, the branch of chemistry that deals with the numerical relationships and mathematical proportions of reactants and products in a chemical reaction.
Limiting reactant, the reactant in a chemical equation that limits the amount of product that can be formed. Excess reactant, the reactant in a chemical equation that remains when the limiting reactant completely stops.
If you have 5 patties, 7 lettuce, and 6 sets of buns, how many Krabby Patties can you make? Our balanced equation for this is 1 patty plus 1 lettuce plus 2 buns equals 1 Krabby Patty. By following the equation, we can only make 5 Krabby Patties, and there was 2 pieces of lettuce and 1 set of buns left over. So that makes the limiting reactant, the patties, and the excess reactants, 2 pieces of lettuce and 1 set of buns.
If 2.5 grams of nitrogen is reacted with 15.9 grams of hydrogen, which is the limiting reactant? The given is 2.5 grams of nitrogen and 15.9 grams of hydrogen. The unknown is the limiting reactant. First, we have to balance the equation. N2 plus 3H2 yields 2NH3. Then we have to create the BCCA table. First, we have to convert 2.5 grams of N2 to moles. To do that, we need to find the molar mass, which is 28.02 grams of N2. The molar mass is the mass of a substance in 1 mole. Then we get 0.09 moles of N2. Then we do the same process for hydrogen, and we get 7.9 moles of H2. Next, we have to convert moles to moles. We have to use the mole ratio, a conversion factor that relates the amounts in moles of any 2 substances in a chemical reaction. To do that, we need to look at the coefficients. The hydrogen has a coefficient of 3 and nitrogen has a coefficient of 1. So we take 7.9 moles of hydrogen and divide that by 3 moles of hydrogen to find the amount of moles of nitrogen, which would be 2.6. You would do the same process for the rest of them. For 7.9 moles of H2, you would need 5.3 moles of NH3, and for 0.09 moles of N2, you would need 0.18 moles of NH3. And for 0.09 moles of N2, you would need 2.7 moles of H2. From the calculations below, we fill out the table. For the first change, we assume that nitrogen is the excess, and the second change, we assume hydrogen is the excess. We use the change that had the excess amount of hydrogen because it created the least amount of product. The reason we cross out the change with the excess of nitrogen is because the products are larger than the change of excess of hydrogen. Then we subtract the before products by the change of excess hydrogen products to get 0 moles of nitrogen and 5.2 moles of hydrogen and 0.18 moles of NH3. After completing the table, we found that nitrogen was the limiting reactant and hydrogen was the excess reactant.
In this video, you'll learn the definition of limiting and excess reactants, stoichiometry, the molar mass, and the mole ratio.
We showed simple and complex examples of the process of finding a limiting and excess reactant.
How to fill out a BCTA table,
How to complete calculations from grams to moles and moles to moles.
and how to find the limiting and excess reactants in a reaction.
Chemistry is cool.